Okay, that's cool. So sure, why not? So what can you tell me about limits?
What's happening to a function as it is going to zero?
Oh no, copy. Can you say that again?
What's happening to a function, I assume, as it reaches zero, or as it comes to zero from both ways.
Okay, so does it have to be zero? No, so it doesn't have to be zero. So maybe okay. So anybody else have a different idea about limits? What do you know about limits?
Like restriction,
Is what?
like restriction.
I can see that. I can see some type of restriction. Yeah. Yes.
Could be worse.
Could be something where it's undefined. Good so far. Very good. Anybody else? Yes. I guess limit can apply to any number, so you technically are okay still. How about the rest of you guys? Just have no opinion, no ideas. Tyler? No? It could be infinity. Could be infinity. Could be infinity. It could be x approaching infinity. I like the word approaching. Anything else like to add? No? Okay. No, that's good. Let's just say if I'm trying to come up with an analogy. Uh, have you seen Dragon Ball? Anybody ever seen what Dragon Ball when they grow up? A little bit. You know how the whole episode of Dragon Ball is they have this radar, and then they go look for Dragon Balls, right? And they can see they have this radar. They can say, oh yeah, the Dragon Balls is right there, and it's go search for it, or dive underneath the ocean or whatever, or in like whatever in the situation. That the whole series, the beginning series, talking about how to find the Dragon Ball. So basically, taking GPS, go search for that thing. So right now, what if I say the things that you're searching for is a black hole? Okay, it's a black hole that we cannot search. Um, we cannot, at least we cannot take a GPS on top of the black hole. Um, uh, I mean, I don't know. There's a YouTube video talk about like I don't know what's that channel name. Start with a K. Um, uh, that channel was talking about like how many ways I can die in the black hole. Have you seen that before? Like one way to die is like spaghettification. Do you guys know that? Yes, spaghettification. Yeah, because of what happened in black hole, it was like a very, very large gravitational pull. So imagine that gravitational pull is infinite. So it basically pull you like just stretch you becomes like a spaghetti, and it will become you become pretty much atoms just like stretch so fast. I think that's a like for me like if I have one way to die, I would definitely choose to die that way. Um, at least the pang is gonna be very very short. It's like probably like 1 second. And then you're done. And you can't even hear the voice. The voice kind of dissipate throughout the airs. So at least like that will be one way to die. So like how old people like they want an injection to die. I think they should have like throw people in a black hole, ship them to the black hole, like or create a black hole, just push them there. Yeah, that would be like painless. That would be like no suffering. I mean, maybe 1 second. So you're not even gonna like injection you like oh man, like the poison starts spreading your body, right? So I think that's I think that's a pretty cool way to die. Somebody can invent that. That's how my death's gonna be. Um, So yeah, that's that. Um, so imagine that we have a black hole on the ground, right? So what we're gonna do is we're gonna maybe turn it this way. Okay, so we're gonna clear the table here. Okay, so let's see which people I like. Anybody's not sick. Look, are you sick? If you're not sick, okay, we're gonna use. Come on, clear the table out. And yeah. Okay, so let's just say this black hole right here on the ground, like between the tiles, right? Right between the tiles here. And what we're gonna do is we're gonna take it there. We're gonna say go over there. I don't know if you ever like I say I remember like I grew up with a family with 7 kids. So we get into fight all the time, and this how we get into fight is we use limits. I'm serious, and we use limits.
Asian type fight.
Yeah, it's an Asian way to get it back. So what we do is we take a finger and we just point at them and we can get like, I'm not touching you, I'm not touching you, I'm not touching you. Have you done that before?
Oh my god.
You did that?
No, my little brother.
Did that to you? Okay, so I'm not touching you, I'm not touching you until you get really mad and your little brother come to you like, they use a limit. It's called approaching like slowly. Like very, very slowly. And very, very close, very, very uncomfortable. Right. So I actually that's the way that you get in a fight because eventually you slap him and then you start crying and then your mom come into you and like why you slap him? It's like what is that? And then your brother's crying, it's like I never touched her. Is that true?
It's so true.
It's so true. Okay, so that's limits. You're approaching something slowly but you're not gonna be there. So same thing, if I have a black hole on the ground, right? What we're gonna do is we're gonna approach from both ends. We're gonna approach it very, very slowly. Very, very, very slowly. So what we're gonna do is we're gonna take half the steps, right? We're gonna approach this. We're gonna take a GPS and we're gonna approach slowly. So we can both take one step here, and so we're gonna get to here, right? So we try to reach this bar. Try to reach this black hole right here. And then, but we cannot take a GPS set on top of black hole. We have to approach even slower. So we're gonna take a half the amount of steps going to here. Come on, don't worry, I'm not kissing you.
Oh, boy.
Yeah. So heavy.
Really
So
close.
yeah, really, really close. And then we can take a GPS and we say, oh, okay, I'm approaching a value of negative. Maybe I'm approaching here, and I'm gonna say my coordinate is 4, and his coordinate is let's say 2, right? And then we're gonna take half steps. I'm gonna say, hey, and my coordinate is gonna be what? Maybe 3, maybe 3.5, and maybe 2.5, right? And we can get closer until we get really, really comfortable with each other. But I'm not kissing him because that's law. That's me getting fired. So what we're gonna do is we're gonna approach something very, very slowly, and we just take a GPS. We're gonna approach it. We're gonna record out a value every time. But the whole idea is we cannot stand on top of a black hole. Unless I'm smart, I'm gonna push him into the black hole, right? So that's not a good idea. So, but we just approach it slowly. But thank you.
Still welcome.
Huh?
You're welcome.
Okay. So the idea is you're gonna approach very, very slowly from both ends. Both ends. Now there is something also approaching from one end. It's called one-side limits. But in both ends, we just call it limits. Okay, so now, with that being said, we're gonna teach you how to use decimals. So sometimes you have to learn how to approach a couple of ways. So you can approach limit using graphically, numerically. So we're gonna start with numerically. Okay, so I'm gonna go back to iPad. Pretty cool, right? Okay, so limits. Okay, so please don't call it lim, but math is gonna show up as LIM. But don't say lim, it's limit, just say limit. Um, this is the part that usually I will say, hey, let's do limits as x approach a value. Now, what looks as approach 0, but does not happen to be 0. Yes, of course. It does not have to be 0. It could be any other value. So right here, we're going to approach 0 because 0 is easiest to approach. And then we got a value of x of square root of x plus 1 minus 1. So this is a function. Hopefully you see what happened. What happened if I approach? Okay, let me ask you a question. Let me ask the breakout question. What is domain of this function? What is domain of this function? Let's talk about if this question is a breakout. This is a question I will ask you. What is domain of this function? Let me hold my breath.
No, negative one. Negative one. It's a negative at the bottom, so you have to make it move one.
I'll do that. Can I move to that seat over there?
That's what you said. Positive one. Impressive, you can hold your breath out, man. Read it.
Bracket -1, 0, parentheses, 0 to infinity.
That can at least kind of saved me there. Almost. Maybe I think most of the things are correct. So there was two type of domain issue. One is the type of domain that you're gonna have issue is when denominator is equal to 0. So denominator cannot equal to 0, right? Because the denominator equal to 0 is undefined. And another thing is inside a radical has to be greater or equal to 0. Why? Because if it's less than 0, it can square root of -1, right? Square root of -2. That does not define. So there are two situations. So usually I take care of one situation at once. So denominator cannot equal to 0. That means I'm going to do x plus 1 minus 1 cannot equal to 0. So x plus 1 cannot equal to 1. If I square both sides, x plus 1 cannot equal to 1. Am I okay? And x cannot equal to 0. That is first things. If x equal to 0, then the bottom is equal to 0. If bottom equal to 0, there are two things can happen. One is called removal discontinuity, and the other one's non-removal discontinuity. I don't know which one's which, but it's some type of situation. So that's the first thing. Now, second thing is inside a radical has to be greater or equal to 0. So x has to be greater than what? -1. But can it be -1? No, it can equal to -1. Because in square root of -1 plus 1 is what? Square root of 0. Square root of 0 is what? 0. And the bottom is going to be -1, top is -1, so the answer is going to be 1 when it's at -1. So technically you have to listen to these two things to create a domain. So what she said is -1 to 0. Now what she forgot to say is this one should be a parenthesis. But since I cannot hold my breath anymore, and I don't want to die in classroom because student cannot answer my questions, that'll be a sad way to die. Please push me to a black hole if something like this happens. So union from 0 to 1, or 0 to infinity, and a parenthesis right here. Does that make sense? Two situation, your domain. Always check those two situations. There's another situation with limits. Where the limit of something has to be greater than 0. Not equal to 0, but has to be greater than 0. That's another thing that you have to know is the limits. No, not limits. Natural log. If natural log of something has to be greater than 0, you cannot natural log of -1. You cannot natural log of 0. You have to natural log of some number greater than 0. So if it's natural log, then you have says inside the radical, inside the natural log has to be greater than 0, not equal to 0. So those are the things. So first, second, this is a domain. This is how do you find domain. Okay, find domain. Denominator cannot go to 0, first of all. Inside the radical has to be greater or equal to 0. And sometimes you have to do both. This case, you have to do both. Are you confusing? No. Okay. Another way you can think about this is you draw a number line. You know at 0, it's going to be an open circle. And at -1, it's going to be a closed circle. It's going here and here. So that way to tell, like far as graphic notation is -1 to 0, but not including 0. 0 is open circle, then 0 to infinity. And that's two intervals that this function, this domain of this functions. Got it? Next thing. What happened when they reach 0? What situation am I going to get? Huh? Okay, so he says undefined, but it's not really undefined. Yeah. So obviously, if I plug in 0 here, it's going to be 0 over 0 plus 1 minus 1. So 0 over square root of 1 minus 1, that's equal to 0 over 0. Now, 0 over 0 is not undefined. Let's talk about what is undefined though. If you have a number over 0, that's undefined. If you have 0 over number is what? 0, because that's just 0. But you cannot have a number over 0. Number over 0 is undefined. Now, if you got 0 over 0, which is a new case that we never studied before, and we're going to call this indeterminate. I don't know how to spell it. I think that's right. Indeterminate. So 0 over 0 is indeterminate. Now, in Calc BC, which is some of you guys are taking BC, then it's going to be 6 different ways to be indeterminate. This is only one of the most popular way. 0 over 0 is the most popular way. But you can have infinity to infinity, infinity over infinity. You can have infinity subtract infinity. You can have all different kinds, but there's total 6 kinds. But right now for AB goes, it's going to be, this is the major one, 0 over 0, indeterminate. More than one form of indeterminate, right? There's 6 forms. This is one of the most popular form. The second most popular form is infinity over infinity. You're also going to see that this year. Not as often, but you're also going to see that. So obviously, you got 0 over 0. It's indeterminate. You don't know what happened at there. And we're going to show you that. So let's rewrite this question again. Let's say, hey, well, what is this is? So what we're going to do is we're going to approach, and I like what Omar says about approaching 0. So that means I assume that I can go so close to it. Assume that I can get there, right? What will happen? is that going to give me some type of output? Now, we're going to approach 0 using, we're going to use find limits using numerical approach. Numerically. So we approach it numerically. That means I'm going to plug in the number. I'm going to plug in the input. And I mean, there's no way I can do this by hand, so I'm going to do it on decimals. So you guys get a calculator out, or decimals apps out, and you guys going to type in this equation. X over root x plus 1. And you guys are going to learn how to use decimal because that's going to become your best friend. So I cannot get down there. Okay, that, and that's going to be -1. You can download this app. It's completely free. And then you can play this. You see this beautiful graph. And after you see this graph, for today's homework, you're going to have to approach slowly using numbers approach. So you're going to learn how to use calculator. Now, I can teach you how to use TI Inspire, but no, not everybody have TI Inspire now. So I'm going to teach you how to use decimals. Decimals is going to see that flower right top of the equation. They look like a wheel or flower or some type of this. You click on it. So once you click on it, this table will show up. You're going to plug in the table here. And what we're going to do is we're going to approach 0. But obviously, you see 0. What happened? It's undefined. But also, you see -2 is also undefined. But there's two reasons why it's undefined. The first undefined is because you got square root of a negative number. And that's why it's undefined. Because that's not part of domain. Bless you. Okay? So what will happen, the more interesting, I'm just going to get rid of all this value. I'm going to say this. Oops, my bad. I'm going to go from here. Okay, I'm going to approach some type of value. And this is the value I'm going to approach. Now, the point of interest is 0. What happened at 0? Undefined. We don't know what happened. So before 0, I'm going to approach it. Just like me and Luke. So Luke is going to approach from the negative side. So we're going to say -1. And Mr. E is going to approach +1 from 1. We say that's not close enough. That's not exactly where is what I want to be. So I'm going to say I'm going to approach 0 even closer. I'm going to say, hey, let's go into 0.5. And here, I'm going to, oops, this is negative. This is negative 0.5, and this is 0.5. Do you guys know how to use the decimals now? How to build a table? And next value, I'm going to say I'm going to get even closer to 0, but I'm going to do it on a negative end. So it'll be negative 0.1. Is that okay? And I'm going to do 0.1. Do you see the value, the output is 1.9486833, and the other side is 2.4880888. Do you see that? Now I'm going to approach even closer, negative 0.01. And from this end, I'm going to approach, oops, my bad. I'm going to approach 0.01. Do you see the value is going to what? Come closer to 2. And we can verify even that. So we're going to approach to negative 0.001. And we're going to approach 0.001. And you see that one value on the left end, from the left side, is 1.999 for first 3-digit number. And from the right side, it's going to be 2.000488. And you see that as I'm getting closer to there, it still becomes undefined. But I can say it's because I cannot stand on top of 0. That's a black hole. It's very, very tiny, small, infinitesimal, small black hole. Right? You cannot stand on top of it. But we can go so closer because this black hole is so small, I can get very near it. If I get near it, I can find a location of this black hole. And this location is going to be probably more likely to be 2. Is that okay? Is this confusing?
Trying to find them, like, is it always a whole number? Would it work to be a whole
Not necessary. It could be 3/2. It could be 1/5. It could be 1.05, 1.27. It could be a lots of things. Yeah, it doesn't always have to be integer. No. Yeah. We can say that more likely safe to say is probably going to be 0. If you want to be safe, then just go and approach even smaller to where it says, hey, negative 0.0001. Now this is 30. It's 4/9, and I hear it's going to be 0.0001, and that's 2.00005. Now, probably safe to assume it's going to be somewhere in the middle, right? So imagine Luke's on the other side, and the mystery is coming from the other side, and we say, no, we're not going to kiss each other. We're going to say, that's it, right there. It's about right there. That we might end up kissing each other at that place, but it's not going to be. Don't worry, Luke, you're not my type. Yeah. As much as you think you are charming. Sorry to this point. Okay. Is that okay? So therefore, limit x approach this according numerical approach that's equal to 2. Not something crazy. Not something like.
You would rather answer as limit of x approaching to 0 is equal to 2.
Yep, numerically. Now, there were 3 approaches that you can approach. Okay, this is what calculus wants you to know. One is called numerical approach. Second is called graphic approach. You can also talk about graphically. And 3 is algebraically. I think that's how to spell, but I don't care. And 4 is analytically. So you got 4 approach. It's called rule of 4. One is called numerical. You can approach a number slowly. Second, you can look at graphically. In math, you got to look at this 4 perspective. You cannot restrict only one perspective. But I will say most often in math, I'd rather you approach graphically, algebraically, and analytically. I don't know how to spell analytical. A-N-A. People are spelling B champion. Luke. Analytical. How to spell analytical? Jordan, do you know how to spell? All right. Analytical. Okay, whatever. I'll just assume that's right. I don't know. Could be right. So you can numerically, graphically, algebraically, analytically. So in the future, when you're doing math, you should think about all those 4 things. If I approach a number close, like approaching a number and slowly approaching, that's the dumbest way to approach, but this is one way I'm going to teach today. The second way is look at a graph. Think about what graph will be, and we're going to talk about that in a second. Think about graph will be. Algebraically is to able to do math, which is most of the time we test this part. But if you don't including graphically, you're not a very good student. So you should always think at a minimum graphically and algebraically. That's a level who can score a 4. If you can think about analytically, let's think about what math will happen, right? And think about all the possibilities can occur. Those are analytical, then you are for sure going to get a 5. And somebody who can do analytically only, they don't have to even know how to do algebra. They can get a 4 or 5. So you have to think about the best approach. The best approach to get you most of the points is going to be algebraic approach and graphic approach. Analytically, you have to have something, some portion of it. Numerically, you don't have time to do that. Okay, but this 4 perspective, that's the things you want to look at. So before that, we're going to talk about when this limit does not exist. Limit does not exist in the three situation, 1, 2, and 3. I'm gonna give you all three situations. The first situation is limits x approach at the value from the left. That's a minus. That's a superscript. So of f of x does not equal to limits x approach a from the positive superscript of fx. So if you're approaching from the left side, so let's say Luke approach from the left side, and he's got an output of 2. And if I approaching for the right side, I got an output of 4. That means limit does not exist. Because we come in the conclusion says, he says black hole is at location of 2, I say black hole is at location of 4, then therefore we cannot get into conclusive decision. Then we're gonna say limit does not exist. Does that make sense or no? And we're gonna talk about graphically. I'm gonna show you example graphically. Now, next thing is this. The next thing is unbounded behavior. So unbounded behavior, and which is more likely is some type of vertical asymptote. Okay, vertical asymptote. I'm gonna give you an example on that as well. And lastly, my favorite kind is oscillation. This oscillation is kind of cool. I'm gonna talk about that situation. Okay, so examples. What will be an example of limit x approach a of left side of fx does not equal to limit x approach a positive side of fx? So I'm gonna assume that there's a f of x here, and I'm gonna ask you to think about graphically approach. So you can, without using calculator, I want you to figure out how do I do absolute value of x over x? What do you think that graph is? Think inside your head. Use your pencil if you need to, but do not using graphing calculator graph absolute value x over x. I want you to think about what would this graph look like. And I'm gonna ask you a question. I'm not gonna say yes or no. I'm just gonna nod. Okay, I'm just gonna nod. And I'm just gonna ask you guys feedback. What would this graph look like? So start with, anybody wanna challenge themselves to figure out what the absolute value x over x graph without using calculator? What would this graph look like? Can you think about math? This is a part of analytical. Analytical is think about math. What would this graph do?
Y equals 1.
Okay. I'm gonna nod. I'm not gonna say yes or no. Anybody else? Yes.
Would be y equals 1, x is greater than 0, but negative 1 that's less than.
Okay. Anything else? Anybody else? Yes.
Small v.
Small v. Okay, I'm gonna nod. Like I said, I'm not gonna say yes or no. I want you guys to think. This is where I'm trying to develop your thinking skill, analytical. I want you to evaluate what other people says. Anybody else?
Increasing or decreasing is like constant.
Okay. Anybody else? Isabel, what do you think? Okay. Giovanna, what do you think? Elise, what do you think?
No, I agree with them, but when it's negative, it's negative 1, and when it's positive, positive 1. I don't know what
Yes.
happens at 0.
5 0. Yes.
Would it kind of just be like a straight line broken up to 0, like never touching 0?
Possibly. I don't know. Brady, what do you think? I like that. I like it. That's good, interesting. Okay, Mario. No. Okay, so I like look. Look was the first one to suggest. I say it's look like maybe something like this, and then you changed it, which is good. Jamie says maybe small version of that. So they always start thinking about absolute value graph, but they did not consider the x on the bottom, right? You didn't consider the x on the bottom. Now Omar's start the first part of thinking says maybe on the right side, maybe it's a positive one straight line. And then Tanner on the back says, well, I think he believed that on the right side it's going to be positive one, on the left side it's going to be negative one. And there's, Isabel said similar things. And then he said something about indeterminate at 0, which is super good idea. So a lot of you guys are generate good things. So now that's analytical thinking. Is think about what can possibly be. Because that's open-ended thinking as opposed to just singular direction and angle thinking. So it's not like, just algebraically or graphically. So what we're gonna do is we're gonna graph it and we're gonna show you, because that part is that I need you to develop is to be able to think without using graphing calculator, and that is a analytical thinking. But if you are absolutely right, it looks like this. This is the first time you've seen this graph before. Not only that, let's talk about indeterminate. That was undefined. That was an open circle, right? And it cannot reach. There's open circle on both ends. There's an open circle. So the graph looks like something like this. The graph looks like something like this. And that's analytical thinking. That's analytical thinking. Now let's talk about algebra thinking. Algebra thinking is gonna actually, I'm gonna introduce you something that you never learned before, but it's supposed to be taught on Algebra 1. Nobody taught it, and at least no teacher willing to take a risk of teaching that. It's called definition of absolute value. So we're gonna come back to talk about this. We're gonna start with a definition of absolute value. Absolute value. The definition of absolute value is if f of x equal to absolute value of x, right? And then if you want to write in a piecewise function, which is you can write in piecewise function. But first of all, let's graph this. If I have a value here, and I'm going to do it in terms of red function, this is red. That is going to be here. Is that okay? And this is going to be blue function. It's going to be here. Is that okay? So I'm going to color code this red. So red is going to be, sorry, that was not wrong in color code. The red is going to be x when x is greater than 0. And this is a negative x when x is less than 0. Now, put in mind there are two different functions. On this function is going to be a x, and the best way is I always put a parenthesis right here to help you thinking, and this part is going to be negative x. On the left side is going to be negative x, on the right side is positive x. This is called definition of absolute value. Definition of absolute value is basically write the absolute value in terms of piecewise function. Am I going too fast? No. Okay, so I'm going to ask you to practice this one. How do I write this in piecewise function? Absolute value x minus 2. What is the best way to think about this in terms of piecewise function? What's the right side of the function? Well, first of all, let's think about the graph first. What will be the graph? What does the absolute value x minus 2 do? To the right, good. Do not tell me down and do not tell me left. It's to the right, so that's good. So the right side of the function, there was a function like this, it's 45 degrees angle, and there's another function on this side. So can you tell me the left side of function, right side of function is going to be? Well, the right side function is just basically the positive function of that. So it's a positive in front of the absolute value. So it's going to be x minus 2. Is that okay? From the left side, it's going to be negative of x minus 2. Is that right? Put a negative, put a parenthesis. So negative parenthesis of x minus 2. And this one is going to be x minus 2. And this one's x is greater than 2. And this one's x less than 2. And why do I choose 1 is greater equal to? Because you still have to throw in a solid dot. So I can write this in terms of piecewise function.
You can choose which one's greater than equal to.
I usually choose a positive one, just kind of makes it easier, and the other one just gonna be less than. But it doesn't matter. Because as long as you fill in a dot, that's fine. Is that okay? You can write in two, every absolute value you can write in two functions. One is the positive version of a function, one's negative. You're gonna understand this. This is gonna be so easy when it comes down to taking derivative or finding integration of absolute value function or finding a limit of absolute value function. It's so much easier if you think graphically. This is how I test. When students walk in my room, they say they're good at calculus. I have kid coming back to double block, and I ask them a question, and they cannot answer. It is because they don't know how to think different perspective. And I want kids to be able to think different perspective all the time. And that's the part I want you to think. So that is the two functions. Now let's go back to talk about this function. F of x equal to absolute value x over x. Can I write this in two pieces? Well, if I write this in two pieces, what will happen? When x greater than 0, it's going to be is x over x. Is that okay? Is that okay? Because I choose the positive version of the x. And when x is less than 0, what happened? Negative x over x. Can I rewrite that? The piecewise function is going to be 1 when x greater than 0. This is negative 1 when x is less than 0. Now I can graph it. Am I going too fast? Let me know if I'm going too fast. This is like this, and this is like this. Now, if I were to limit x approach from 1 of 0 from the left of absolute value x over x, it's going to be what? If I approaching here, right? What is it going to be? What is the output? Well, this is 1. So this is 1. Yeah, I just think I wanna show people that this is a 1, this is a negative 1. So it's gonna be what? Negative 1. Good. What happened when limits x approach 0 from the positive side? That's equal to what? That's equal to what? 1. And does that make sense? Well, limits x approach 0 from the left side of absolute value x over x is is equal to negative 1, and does not equal to limits x approach 0 from the positive side of absolute value x over x, because you got negative 1 and 1. So therefore, limits x approach 0 in general of absolute value x over x does not exist, because we just proved the first scenario of does not exist.
So it does not exist because it's not equal to each other?
It's not equal to each other, exactly. Even like 0.1 difference is still not equal to each other. 0.01 difference, it has to be exactly the same value from left side and right side. Because we want to be sure this is a black hole. We want to make sure this is a black hole that we cannot step on. Right? We cannot just say, well, maybe it's there, maybe it's not there. No, you cannot do that. You have to be for sure. Is that okay? Okay. Next thing. Next situation, this is the example for 1. For this example right here. Which is, you need to know definition of absolute value before you get there. Now your next thing is going to go in from what? You're going to say, okay, well, second situation, unbounded behavior. it's gonna be what? Well, 1 over x squared. You guys should know what 1 over x squared is look like. First of all, you have to know what's f of x, 1 over x look like. What's 1 over x graph look like? Do you guys know what the 1 over x graph look like? Not upside down problem, no. Okay, there's an asymptote, yes. What else? It's called reciprocal function. The graph's gonna look like this. And like this. And when I taught algebra 2, I usually told students like if Mr. Ye were to create a gang inside the school, and that's gonna be a Ye gang, and that gang sign is gonna look like this.
That's a wild statement.
Huh? That's gonna look like this. It's on the first quadrant and the third quadrant. And so there's a vertical asymptote, there's a horizontal asymptote. Vertical asymptote at x equal to 0, horizontal at y equal to 0. So there is an asymptote right here, and there's an asymptote right here. And that would be the gang sign that I would do. Okay. So, but if that makes 1 over x squared, that means both sides going to become positive. That means both sides become volcano graph. So limit x approach to 0 in this case, it'll be two situations. Usually right now we're going to call it undefined. We're going to call it does not exist. But sometimes they can say that's this one is limit x approach to 0 of 1 over x squared. Sometimes they say it's a positive infinity or does not exist, but not both. That means both answer is not going to present exactly at the same time. Sometimes they can say it's a positive infinity. Sometimes they say it does not exist. Now in this case, limit x approach to 0, according graphically, that's for sure does not exist because one's reaching positive infinity, one's reaching negative infinity. Do you see that? So one's going up, one's going down, right? What time we get off here? 10:06. Okay, I'm gonna miss the last part. The last part is the most exciting part, but you guys probably have to watch. X approach 0 of sine of 1 over x. This is oscillation. Now you probably had to watch the video here, which is the last part of the video. It's only like 10 minutes long, but it's very, very important for you guys to understand. I'm gonna try to make a video again that including this part. Okay.
Can you explain your 1 over x squared and how it's infinity?
What?
How it's infinity?
Because if you reach from the left side, it's positive infinity. If you reach from positive, it's infinity. But technically, in the calculus textbook, you even have ambiguity here. They say this could be a positive infinity, or it can be does not exist. Because unbounded behavior, if you look at unbounded behavior, it does not exist. And if you look at it from one side limit perspective, that will be go to positive infinity.
And D and E means
Does not exist. Does not exist.
have a good industry.
Me too.
This is limit x equals infinity also equals to 0 that does not exist.
Yeah, so it not both. Either be positive infinity because due to one side limit, or it can be does not exist due to unbounded behavior. But it's